The American Diabetes Association is committed to the treatment and prevention of diabetes. While thousands of the top researchers and physicians are coming together to showcase the latest advances in research and treatments, ADA TV is bringing you the best in breakthroughs from the 84th Scientific Sessions. Welcome back to Orlando and to our fourth and final day here on ADA TV. I'm Autria Godfrey. Diabetes isn't just a disease, it's an epidemic. And with nearly 98 million American adults living with prediabetes, today we are highlighting the latest scientific achievements working to reverse those sobering statistics.
We invented the world's first automated insulin syringe. That made life a lot easier for many people.
Straight ahead, from the Banting Award winner to the Outstanding Scientific Achievement Award recipient, we're sitting down with those who have made an incredible impact on diabetes research. And backed by popular demand, the Innovation Challenge puts the best and brightest startups in front of a panel of potential funders. We'll see how they fare.
Only then can we begin to understand how diabetes, which after all is a systemic disease, affects the health of people throughout.
And we wrap up our final day of touring the institutions and organizations blazing new trails in diabetes research. Wait until you see the fascinating phenotyping study currently underway. We have got a full final day ahead, and we want to make sure you never miss a minute. You can always find the latest ADA TV episodes on our TVs placed throughout the convention center, on the in-house channels at several of our partner hotels, on the shuttle buses to and from the venue, on the ADA Scientific Session website, and on our X and YouTube pages. But first, we get started today, just like we have each day this week, with Dr. Alice Chang. And it's been an incredible week full of emerging science, breakthroughs in diabetes research. Anything in particular that has stood out to you over these last couple days?
So many to choose from, so it's really hard to pick just one, but I think one of the ones that I'll pick is there was a panel that I attended which was looking at treatment choices for newly diagnosed diabetes, and people sort of presented different positions, but what was great fun was actually the audience questions. Oh. And there were some really entertaining questions that came out. You could tell that people knew each other. There was some hazing, which was maybe appropriate, but very entertaining and still educational and still collaborative. But I think that's really one of the big values of being at the in-person one, certainly, is being able to hear those questions and see that camaraderie.
And all in good fun.
Absolutely.
Yes.
Absolutely.
Any key piece of research or any results from a clinical trial that really stood out to you?
Again, lots to choose from, but I think there were a few game changers, I would say, that I just want to bring out. So I think the LENS trial, which is the trial looking at the use of fenofibrate, that's sort of an oldie but a goodie. I mean, an old medication we may not have thought about that much, but fenofibrate for diabetic retinopathy. Oh, okay. And randomized controlled trial demonstrating that it does in fact slow progression. So offering a systemic therapy for diabetic retinopathy, I thought that really stood out. Yeah. I think SURMOUNT OSA definitely stands out for tirzepatide and its ability to lessen the burden of obstructive sleep apnea, and many of our patients certainly have obstructive sleep apnea. That one definitely stood out to me. And then on top of that, INHALE-3. So INHALE-3 was a clinical trial of inhaled insulin plus basal insulin versus usual care in type 1 diabetes, and demonstrating benefits of the inhaled insulin. So I think really giving a lot of clinical information as well that we can take to our practices.
And those clinical trial results are such an integral part of the scientific session, so certainly something we want to highlight. All right, our final day, what's on tap for Monday?
Lots on tap for Monday, so I think people can hopefully still have lots of energy left after the previous 3 days of learning so much. We're going to start off the day at 8 a.m. with the fan favorite, which is the year in review, which everybody usually really likes. So we're going to hear from the basic science, translational science, as well as clinical science, and year in review, sort of highlights from the past year. At the same time, there's also going to be the world premiere of consensus guidance on monitoring for early stage type 1 diabetes, which I think will be very useful for us to hear about. And then later on in the morning, we're going to get the award lectures. So the Outstanding Scientific Achievement Award lecture and the Banting Award lecture. So those are always very inspirational.
Yes.
Then in the afternoon, we're going to hear from the FLOW trial, which has already been published, but it's always great to still hear more information, and we always hope that there's some new information that gets presented at that time. And then at 3:15, there are some significant studies that are all going to read out at the same time. We're going to hear from the TIGHT study, which is looking at continuous glucose monitoring in hospital. We're going to hear from the ATTEMPT study, which is looking at SGLT2 inhibitors in youths with type 1 diabetes. And we're also going to hear CATALYST Part 1, which is looking at hypercortisolism in type 2 diabetes. So sort of a topic we wouldn't necessarily have thought of. And that's just naming a few. I could go on and on, so I encourage everyone to certainly take a look at the program. And again, to remember that they can still access stuff on demand if they miss anything that they really wanted to see.
Right, they can go back and watch. Well, it's been an incredible week and still one more jam-packed day still to come. Thank you so much for all of your work as a part of the planning committee and for being with us today.
My pleasure. Thanks for having me.
When it comes to acknowledging scientific achievements, Dr. Rory Holman has received the top honor. The Banting Medal for Scientific Achievement recognizes significant long-term contributions to the understanding, treatment, or prevention of diabetes. And Dr. Holman is here now in studio with us with an overview of his work being recognized. Such a pleasure to have you with us today.
Good morning.
Well, let's get started first off with the big congratulations. What a well-deserved honor. How does it feel to be recognized by your peers in this way?
Well, surprising. Surreal, humbling, and truly a great honor, particularly as a clinician. So I've been fortunate to work with the lead people in over 40 countries for many years. And I like to think this honor reflects our collective efforts and those of my team in improving the lives for people with type 2 diabetes.
And that you are doing. Let's talk about your work. You've confirmed that declining beta cell function was the main driver for type 2 diabetes. How did you determine that?
Well, insulin levels in people with type 2 diabetes are high. But that's at the expense of high glucose levels, which go on to cause complications. So we reduced the insulin levels by injecting fish insulin, measured the human insulin, and it was low, confirming that beta cell function was insufficient. Then in UK-PDS, year by year, beta cell function declines by 4% per year, whatever the treatment, and that results in progressive hyperglycemia, again producing complications.
And your findings actually disputed the assumption that insulin resistance was the main factor.
Absolutely. So many people have insulin resistance but do not become diabetic. In susceptible people, what happens is the demand for insulin can no longer be met when the beta cell function declines, and it's at that point they develop diabetes. So insulin resistance is a factor, but not the main driver.
Right. Can you also tell us a little bit about some of the automated devices that you have created?
Sure. So when I started my quest for normal glycemia to avoid complications, we had to introduce home blood glucose monitoring, and finger pricking was difficult and painful. So Robert Turner and I invented the world's first automated finger pricker, the Autolet. And then, of course, we found that people had difficulty giving insulin, drawing up from a vial with a syringe. You need manual dexterity, not so good if you're an older person. So we invented the world's first automated insulin syringe. The insulin came in a cartridge, you selected the dose with a dial, and you just pushed a button to give the insulin. So that made life a lot easier for many people.
Right, incredible. What is next for you and your research?
Well, I remain academically very active. I no longer run the unit, but that gives me more time for writing. I have a large amount of data now with the newly acquired proteomic, metabolomic and genetic data from all my studies. So I write about 2 papers a month, and currently I'm co-chairing an Alzheimer's prevention study looking at semaglutide double-blind compared with placebo.
Interesting. Well, congratulations again on this award, and we look forward to seeing what's next for you.
Thank you so much.
Many thanks to Dr. Holman and his work at Oxford. Staying across the pond now, the UK Type 1 Diabetes Research Consortium was set up in 2015 to promote, develop, and support immunotherapy research in type 1 diabetes. See how they are working hard to speed up the process of finding new treatments to preserve beta cell function with the hopes of moving toward insulin-free T1D.
In 2015, 8 of the leading type 1 diabetes research centres in the UK came together as a consortium funded by Diabetes UK.
Since then, 2 more have joined. Now, the consortium has 30 clinical trial sites across the country, involving both paediatric and adult clinical teams.
With 3 quality-assured bespoke laboratories in our mechanistic core, offering state-of-the-art immunological assays in type 1 diabetes, the latest autoantibody measurements, and a comprehensive range of rapid turnaround metabolic analyses, our Study Plus program can enhance and accelerate the delivery of your clinical trial from first in man all the way to phase 3.
And we have expertise in protocol development, alternative endpoints, patient-reported outcome measures, continuous glucose monitoring, and advanced trial design from over 15 years' experience of working in the T1D field. We are moving towards insulin-free T1D. Are you?
Our next guest serves as ADA's President of Medicine and Science, and for him, fighting diabetes is a journey that began in childhood. Our appreciation to Dr. Mandeep Bajaj for sitting down with us here today. Pleasure to have you with us.
Thank you.
I want to get started with that personal journey that you've had. Can you tell us a little bit about your path?
My father was a diabetes researcher in New Delhi, India, who later became the president of the International Diabetes Federation. So I was introduced to diabetes research and diabetes care early in my life. From my school days, I would go and attend his lectures, and he inspired me to take up a career as an endocrinologist in diabetes. I did my medical school at the All India Institute of Medical Sciences in New Delhi, India, India's premier medical school. And it was here that I saw a lot of the complications of diabetes. And that strengthened my resolve to take up a career to make the lives of patients with diabetes better.
Absolutely. Well, let's talk a little bit about your current position. What have been some of your top priorities during your term as president?
My top priorities are, firstly, to ensure that the ADA research funding remains good. And this year, we are going to allot $23 million in research grants. Research funding has been my top priority as ADA president. But also, the knowledge we generate from research must then be disseminated and implemented for better health statistics and patient outcomes. We need to take it to those who care for diabetes, and those are primary care physicians.
What do you think are some of the biggest obstacles in the fight against diabetes right now?
The biggest obstacles are that while we've made rapid advances in technology, we still have not been able to get primary care physicians to really adopt those advances, especially technological advances, in their practices. And that is where the Primary Care Alliance helps to take those advances to primary care practices. I think it is very important that the dissemination of information be a top priority for the ADA. And I think that is an area where we need further work.
You've held a lot of incredible positions over your prestigious career. Any key positions stand out to you as far as you being able to have the biggest impact?
Well, I've held a lot of positions, that is true. But I think the most important position is being the president for medicine and science of the ADA. It has always been my, I would say, dream to serve as president of the ADA. The ADA is a phenomenal organization that works on a daily basis with thousands of volunteers to improve the lives of patients with diabetes. And as a physician, that is what is most important to me.
Wonderful. Well, best of luck over the next 6 months as you finish out your term, and we thank you very much for your time today.
Thank you so much.
Since 2011, Maastricht University in the Netherlands has conducted an extensive phenotyping study focusing on the etiology of type 2 diabetes, its classic complications, and its emerging comorbidities. Check out how they've used advanced state-of-the-art imaging techniques and extensive biobanking to determine the health status in a population-based cohort of 9,000 individuals.
I think that what we call comorbidities are not comorbidities at all. Depression, cognitive impairment, more infections, they are true complications of type 2 diabetes. To understand how diabetes affects the health of people throughout. This is the mission of the Maastricht study.
We decided in 2010 to enroll 9,000 individuals from the southern part of the Netherlands and to study them, deeply phenotype them.
In the research center we have more than 30 different measurements that we collect. With this data we can perform very nice research and improve the treatment of prediabetes, diabetes or cardiovascular disease.
If we want to prevent the extensive vessel damage and neurodegeneration that we consistently see in type 2 diabetes, prediabetes is the time when we should act. Early intervention must be key.
The Outstanding Scientific Achievement Award is presented to someone whose research in diabetes has demonstrated particular independence of thought and originality. Dr. Steve Parker is a leader in his field and joins us now here in studio to discuss this well-deserved honor. It is a pleasure to have you with us today.
Well, thanks, Autria, for the invitation. Thanks to you and to ADA TV and everyone.
Absolutely. First off, congratulations. This is an incredible honor.
Thank you.
How does it feel to be awarded by your peers in this manner?
Oh, it's just so humbling. There's so many talented folks doing diabetes research, and it's such a diverse field, and the specific niche area that I'm in, for that to be recognized, I feel like it's not just me being recognized, but the entire subfield of epigenomics research and genetics. It's really, really exciting.
Let's dive into your research. You've uncovered several notable discoveries about diabetic genetic predisposition. Can you elaborate on some of those? And also, this is something you've been working on for about 15 years now?
Yeah, it's been a while. It started back when I was a postdoc at NIH.
Okay.
And now I've transitioned to a faculty member at the University of Michigan. So there's this really exciting idea that you do a genome-wide association study, or GWAS, and you find all these genetic predispositions to the disease, but we don't really know how they function on a molecular level. And so what my group and many other groups across the world have been focused on is trying to understand those mechanisms of genetic predisposition. And it turns out the epigenome is a critical layer of molecular biology that propagates genetic predisposition onto all the cascades of events that eventually lead to the diabetes disease. And so we've been focusing in that area and making a number of discoveries there.
And you know, you really are a leader in integrating genetic and genomic data into diabetes research. Where did this thought originate?
Yeah, so that's not an original thought of mine. I think back when the human genome was published and completed in the early 2000s, that was always the goal, right? To try to use genetics and genomics and all these other new omic profiling technologies to better enable precision diagnosis and therapeutics for individuals with complex diseases like diabetes. So I was just fortunate to be able to position myself in that space and work with the right people, and we've made some pretty exciting discoveries in that area.
What do you anticipate the study of genetics and genomics, the impact that might have on future diabetes research and treatment?
Yeah, I think the exciting thing moving forward is there's now the latest paper came out in 2024 from a consortium called T2D-GGI, Global Genetics Initiative, and they've identified over 1,000 independent genetic variants scattered throughout your genome that predispose to disease. And the idea is they each function a little bit differently. Maybe one controls muscle biology, another adipose biology, a lot of them involved in beta cell biology, but each individual is a little bit unique. So one person may have predisposition because of beta cell biology, another because of skeletal muscle biology, and the idea is in the future we may be able to partition folks into these different categories to dissect heterogeneity of disease to enable more personalized and precision diagnosis and treatment.
And precision medicine.
Exactly,
Okay.
yeah.
You have a new research center.
Yeah.
What can you tell us about that center and the goal of your research?
Yeah, so this is really exciting. It just is unfolding right now, and the name of the center is called the Epigenomic Metabolism Medicine Center, and it came to fruition because of the support of a number of people I'd like to mention. So at the University of Michigan, there are two departments that contributed to this. Brian Athey is the chair of my department, Computational Medicine, Bioinformatics. Tony Antonellis is the chair of Human Genetics, where I also have an appointment. And then two other institutes, the Taubman Institute, led by Chuck Morant, and the Caswell Diabetes Institute, led by Martin Myers. All those folks came together and said, we need to look more carefully at the epigenome because it's such a critical layer to understanding diabetes, and they've contributed to launching this center, and it will take place within the Caswell Diabetes Institute and enable lots more epigenomic studies moving forward.
And something you might be highlighting during your presentation later today?
Yes, later today I'll be talking a lot about that, so thanks for bringing that up.
Sure, all right. Well, thank you so much for your time today, and again, congratulations on your honor.
Thank you so much.
Up next, we take a trip to Loma Linda University to see their groundbreaking intraneural facilitation treatment in action. This revolutionary non-invasive therapy is offering hope and relief for diabetes-induced neuropathy sufferers.
The Loma Linda University Neuropathic Therapy Center is a research treatment center for neuropathy. It's the first of its kind where we bring a manual therapy treatment that guides circulation directly into the nerves. The center is dedicated to stopping anything that creates neuropathy as well as reversing neuropathy using this modality, intraneural facilitation.
I started coming to the Loma Linda Neuropathy Treatment Center about 2 years ago. It has been a blessing. It's been a life changer for me.
There's nothing worse than feeling a loss of hope or hopelessness or this is my reality. And to know that there's other therapies available, such as intraneural facilitation, to be able to have the experience of this therapy and the ability to be healed.
Turning now to our final debate in diabetes segment, and today we are focusing on artificial intelligence and the role it should or should not play in transforming nutrition and diabetes care. Here now to weigh both sides are Dr. Samantha Kleinberg and Dr. Holly Nicastro. Thanks to you both today. All right, Dr. Kleinberg, I want to get started with you because you say, yes, it is time now to harness AI.
Yeah, I think it's a really exciting time for AI, diabetes, and nutrition all coming together. AI has already had successes in diabetes with FDA-approved devices for diagnosing retinopathy, for clinical decision support, and now nutrition is really the next frontier where we don't have FDA-approved devices or algorithms yet, but they're randomized controlled trials that are now showing a benefit and that actually show personalized diets do lead to better glycemic outcomes compared to Mediterranean diet, and also that there's this massive difference in how individuals react to the exact same food.
Dr. Nicastro, you say, not so fast, we are not quite ready for prime time.
That's right. So we've seen some really exciting proof of principle and efficacy studies, but we haven't yet studied a diverse enough sample of participants for us to be able to say that any benefits we find are going to be applicable to all. So we need more diverse studies on more diverse people, diversity in demographics, diversity in how people access their healthcare, their education, geography, and more, so that we don't risk widening any health disparities.
Dr. Kleinberg, is there anything in particular about using AI that gives you pause?
I think, like Holly, I share the same concerns about, we've studied isolated populations in Israel or in the Midwest. They haven't been necessarily representative of the entire US or even other populations abroad. And so we don't know for sure how well these devices or algorithms are going to work for everyone. I think the results are really exciting and promising. And with AI in general, we always have to be worried about generalizing to new populations, that we might be picking up on something that's not necessarily related to the outcome, that's just an artifact or something like that. And so making sure we have robust algorithms is really important.
Dr. Nicastro, how close do you think we are to being able to completely utilize AI in a clinical setting?
I think we're close. Like Dr. Kleinberg mentioned, we are using AI in other applications, just not yet for personalizing dietary recommendations. For us to make that more mainstream, I think a few things have to happen. Again, studying more diversity, but also making it a little more less burdensome and less invasive to collect some of the measures and some of the biospecimens we're going to need to drive the AI models. We need to make it more acceptable and easier for participants to provide stool samples, for us to be able to access genetic information and more. But I think all of these things are on the near horizon, and we could start to see this become mainstream in about 5 years.
Oh, that's pretty soon. Would you feel comfortable with it being implemented sooner than that if physicians know to maybe take the data with a grain of salt?
We can take it with a grain of salt. I think we need to see a couple key studies publish their data first. The Nutrition for Precision Health study is going to really help to drive the field here. We are studying a very diverse sample of participants there. We also need to continue to weigh the costs and benefits. It's going to take money, it's going to take time, and it's going to take some anxiety for patients to provide the information we need to drive the models. So until we know that those models are going to produce robust and sustainable lifestyle change enough to alter one's diabetes risk trajectory, it might yet not be worth it.
Final thought from you both, and my question is, once we do all feel comfortable implementing AI to help transform nutrition, how big of an impact do you see it having in people's day-to-day lives? You first.
So I'm very excited about the possibility here. I think people do crave personalization. People want to know that this is going to work because this is for me. We just need to have all those caveats in place, make sure we're doing no harm, not widening health disparities, but I think there is a lot of potential here.
Dr. Kleinberg?
I agree with Dr. Nicastro. I also think what's exciting is we can also personalize people's preferences, their constraints, what's available in their local area, right? Do they eat a vegetarian diet, or are there other cultural factors? And that's part of the personalized diet, right? Not just what's going to keep you healthiest, but what actually fits with your lifestyle. And so it might be easier for people to stick to these diets compared to some of the traditional guidance, which is really exciting. Also, it's currently burdensome to collect, stool sample and all these other things from individuals, but it might not necessarily be necessary. And so some of the AI algorithms we're working on might be able to personalize to someone based on other characteristics and get very close to that in a much more lightweight way that doesn't have all the expense and doesn't have all the startup time and energy.
Well, we can all agree that it's very exciting to see how technology is transforming diabetes care. So thank you both so much for your time today and for your each perspectives. Appreciate it.
Thank you. Thank you.
More than 300,000 Americans under the age of 20 have type 1 diabetes, and every year thousands more are diagnosed. To help children and young people navigate type 1 diabetes, new research from Cohen Children's Medical Center and the Feinstein Institutes for Medical Research at Northwell Health show that taking vitamin D could help improve the function of insulin-producing cells.
Since I've been diagnosed with type 1 diabetes, it's really changed my life. I have to make better choices of how I eat. I have to schedule for everything I do and really plan it out better.
The primary treatment for patients under the age of 20 with type 1 diabetes is still insulin. However, there is what we call the adjuvant therapies or adjunctive therapies that we add on to insulin to help modify the outcome of diabetes in the long term. So these are called disease-modifying therapies. And this is where we came in with our study on high-dose vitamin D. Our results show that high-dose vitamin D is safe and efficacious in prolonging the honeymoon phase of type 1 diabetes in children.
Back now by popular demand, the Innovation Challenge. 5 contestants are invited on stage to pitch their concepts for improving the lives of people living with diabetes before a panel of potential funders. Let's see how well their ideas were received.
This is an incredible platform to highlight the innovation, the technological advances that are happening in the world right now in the startup community.
What I'm really looking for is, one, obviously impact. It's got to be impactful. But number 2, does it really fit into the lives of people with diabetes or their providers?
We look for batteries included, entrepreneurs, really ones that want to be part of and believe in the power of community and collaboration.
And everything we do is about supporting the companies that we invest in. Really about moving the needle in terms of helping them on their journey to success.
Our mission is to reduce blindness through early detection of eye disease. And we can do this faster and easier than we have ever done before.
The software platform exists as an algorithm and an app that can be paired with on-market insulin pumps via Bluetooth connectivity, as well as being able to be designed to be integrated directly with an insulin pump software on board the pump.
Everyone on the clinic list receives a safe, secure link to an AI-driven questionnaire. And it helps people to understand their diabetes management in the context of their broader lived experience.
How happy are you and your patients with the delivery model, the volume-based delivery model that you're working under today? Our focus is on creating a virtuous cycle to improve the economics of endocrinologists and diabetologists so that people with diabetes can receive the expert quality care that they need and deserve.
We have developed a technology to make 2 different cell types live together, function together, and benefit from each other.
Judges, are you ready? Have you come to a decision?
It was a lot of discussion, but we also agreed. And the first one for me was Diatech.
I think there wouldn't be a man on the moon if you didn't believe and just go for it. So, Symbio.
The third company is Spotlight AQ.
All right, Spotlight. I'm so proud that we've been able to bring all of these wonderful solutions to people with diabetes. Thank you so much for being here, and thank you for being part of the 2024 Innovation Challenge.
What a way to wrap up a fascinating week. We have certainly enjoyed bringing you specially curated content all week long, from our sit-down interviews to fascinating findings, and we hope that you've enjoyed the tour of the institutions and organizations leading the charge in the fight against diabetes. We may be wrapping up, but our content lives on. You can always find the latest ADA TV episodes on our TVs placed throughout the convention center, on the in-house channels at several of our partner hotels, on the shuttle buses to and from the venue, on the ADA Scientific Session website, and on our X and YouTube pages. Thanks for joining us here on ADA TV. We hope to see you again next year for next year's scientific sessions in Chicago. Enjoy the final day and safe travels home, everyone.